Hi everybody, today we're working on the question 6D from the 2022 higher level paper. As you know, we're working through last year's paper and I'm just doing videos showing you how to answer them. The usual reminder is if you really want to get the most out of this and perfect your skills, the best thing to do is pause it now, try it yourself. If the question up here on screen or it's in your exam papers, whatever you use, try it for yourself and then come back and see, did you get the right answer? Because that's how you know that you're making progress and that's how you know that you are ready to tackle it. If you get stuck, instead, you could just watch the video, or it would be good to go back through that set of notes or chapter in your book. Just try to kind of help yourself as little as possible to see how you get on, okay? All right, with this one, it's very the answers you give are very short. It's kind of just a fact type one. There's no big explaining and no big calculating. So people like these questions in general. I think if you remember the fact and you're able to put it down for your 7-mark question, that's a nice one. So the question asks us to state the thermometric property of 1, a thermocouple, and 2, a mercury thermometer. Now, just to help us, I have put up a definition over here for thermometric property. I've taken it out of the real world physics textbook, but if you don't use that textbook and you have a slightly differently worded definition, that's fine too. Okay, so we're just going to, excuse me, have a look at the definition before we get into the question. You wouldn't need to give the definition in your answer. I just have it here to remind us so that we know what we're talking about, because it's such a quick one. I could just write down the answer here, but if you don't remember where I'm getting that from, that's not very helpful. So a thermometric property, and before I even look at that definition, I'm going to break it down a little, and I know that sometimes physics is like learning a foreign language, and here we go. Thermometric. Thermo, I think most people know it's got to do with like heat or temperature. Again, you would not have to do this for your answer. An extra loop in there, temperature. Thermal, anything thermal to do with that. And metric, maybe, may or may not know, means measurement. Usually, okay? It usually is something related to that. So if you're like a thermometer is a measuring tool as well, okay? So knowing that, so if you're stuck and you couldn't remember your definition, but you had an idea of what each of these bits of words mean, you go, okay, something to do with temperature and measurement. Might just get you started, okay? So, but in theory, you should know all your definitions before you start into this. So here we go. A thermometric property is any physical property that changes measurably with temperature, okay? So something that changes measurably with temperature. The measurably part is important. It means that for every, let's say, increase in temperature, you get an increase in this other property. Excuse me, guys, a bit of a cold. So for, let's say if we answer the question, that'll help us perfectly to give an example. So in a thermocouple, and I have a diagram of one of these down below to go back over as a kind of a reminder, okay? So in a thermocouple, the thermometric property, and you literally, this is all you need to say now for your answer. You would just go EMF, literally 3 letters, and you've got your marks. Or you could also say voltage. They're kind of, in this case anyway, they're interchangeable enough. Okay, so EMF or voltage, got my marks for part 1. All right, and I'll do part 2 as well. And for a mercury thermometer, it's the length of liquid in the column. Or maybe just length of liquid would probably cover you as well, okay? So going back to our definition, just in case you're like a little bit rusty about this, I want to pick the mercury thermometer because I think people can kind of visualize it better. I actually have go down to my picture. Okay, I'll have a look at the thermocouple in a sec, but we've all probably, surely, hopefully, you've all seen a mercury thermometer. If not in the lab, you might have seen one at the GPs, or you might have one at home. So there's just a thin glass tube, and inside them there's a certain level of liquid, and depending how hot it is, the liquid goes up. That's meant to be an arrow. Sorry. So we have an idea about that. And what that means, the thermometric property is how high that liquid rises or how long it gets. So as the temperature goes up down here and the bulb of the thermometer, the liquid expands. That's all got to do with energy. It expands and it starts to rise up and fill up. And it does that measurably. So there's a bit of proportionality. So we know that for every extra degree, there's an extra little bit of liquid going up that we can measure. It's a couple of millimeters or whatever your thermometer is designed for. Okay, so all you need to say to answer that question and get 7 marks is this bit here. I'm just going to box it off. This is my answer, right? And you're done now. You're finished. You got that. If you were responsible and you tried this out first and these are the answers you put down and you're looking at it now going, yeah, got it, super, you're done. I have a sample answer attached. It looks extremely short, and I have the marking scheme as well, and it's short too. That's all they're looking for. But just to do a bit of revision, and if you're happy with that and you feel like you understand thermocouple, you're done. So a thermocouple then is a bit more complicated than our thermometer that we're all kind of used to seeing. And what you have here, you have a cold junction. So you have 2 different wires, a copper wire and an iron wire. Here's my little pointer man. There he is. And they're joined together. One side of it is the cold junction, one side of it is the hot junction, and along here we've got a voltmeter. So a voltmeter, just like we said with meters, measures volts. So when there's a change in temperature, you get a change in the volts here at the voltmeter. That change is like proportional to how much the temperature changes. It's measurable. Okay, so the cold junction is here in melting ice, and you might know that melting ice is at 0 degrees. So it's kept fixed, meaning it doesn't change. It's always kept at 0. And then as your hot junction changes temperature, the voltage here changes. So if you have at home, like I know we have at home, and like electronic thermometer, like the type you would put in your mouth and has like a digital screen that comes up and tells you whether you have a temperature or not. And they're used loads of time. You might even have one in your kitchen. We definitely have them in the lab as well. As the temperature changes here at the hot junction, you get a different change in voltage. And it would be something like this inside in your electronic thermometers that's giving you out a reading. Okay, now they mightn't have cold, but they'll have an electronic way of measuring the temperature. So the cold junction is kept at a fixed temperature. EMF, or voltage, is produced and it's measured as the temperature of the other junction varies. Okay, so the difference between the hot and the cold gives you a voltage, and that's going to tell you the change in temperature as well. Okay, so that one's a bit more complicated than the mercury thermometer. That just the liquid expands because it gets warmer, and we have little graduations on the side of our thermometer telling us how much it's expanded, and we relate that to how much warmer it is now. Okay, if you have any questions about those, like I said, there's some good pieces in your textbooks, but like if that's not clear to you or you're after checking that out and you're not really sure, just send on the questions. I have, like I said, I've attached the marking scheme. If you're looking at that and you're trying to make sense of it, let me know that as well. And as always, if you have another question that's not an example paper question, or it's not the paper that we're working on right now, definitely send it on. We don't have to be going through these in perfect order. We can do another video that answers the question, because the whole idea is just to help you out as much as you can. Don't want anyone to be feeling stuck and lost. Okay, that's it, I think. Thanks for watching. I hope you found it helpful, and let me know if you have questions. Thank you.